Hello everyone, welcome to the 8th and last tutorial session of this course. So as usual this week I will be solving the assignment 8 from last year's course, and if you have any doubts or any problems regarding the lecture videos you can ask me in the comment section or you can unmute and ask. So let me share the screen. So I have shared the screen, and the first problem is, so it's a very easy problem. You are asked to find out the curl of a vector field. So curl of f is just given by determinant of I j k del x del y del z and xyz component of the field. So z, x and y, z, x and y. Calculated, it will be del y minus del z del x plus j hat del z minus del y del x plus k hat del x minus del z del y. So now this term is 0, this term is 0, this term is 0 because we are taking partial derivative, and this is 1, this is 1, and this is 1. So we have curl of f equals to I hat plus j hat plus k hat. So the second option. Now again it's the same problem. You are given a vector field and you are asked to find out the curl. Do it similarly. And x component is y square, y component is z square, and it is x square. And if you calculate it, I will not calculate it anymore, I have already calculated one similar example. So it will be z times 2 times z I hat plus x j hat plus y k hat. Sorry, there is a minus sign. So it will be the last option. And now, so it's a scalar function from Rn to R. So if it's a function of x1, x2 dot 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 Rn, let's say, and so you are asked to find out the gradient of f and then the curl. So curl of gradient of f, and you are asked to show that it is 0. So let's do it in 3D. So sorry, so curl of gradient of f. This operator is del x. Let's say f is a, let's assume in 3D f is a function of x, y and z. So in that case this Napla operator is del x I hat del y j hat plus del z k hat. So gradient of f is then del f del x I hat plus del f del y j hat plus del f del z k hat. Now to take the curl, then curl of gradient of f, it is I hat j hat k hat del del x del del y del del z, and x component of grad f, that is del f del x, this one. Y component of grad f is del f del y, z component is del f del z. Now to calculate the determinant, I hat times del 2f del y del z minus del 2f del z del y plus j hat times del 2f del 2f sorry del 2f del z del x minus del 2f del x del z plus k hat del 2f del x del y minus del 2f del y del x. Now if it is a differentiable function, so that means these partial derivatives, so these are commutative, that means del 2f del y del z equals to del 2f del z del y, and because of that this term will be 0, this term will be 0, this term will be 0. So basically what you are getting is a null vector. So the statement is true, curl of grad of f is 0. Now the fourth problem, this is also a very easy problem. So we have to find out the divergence of V, and V is given by this. So divergence of V equals to del del x I hat plus del del y j hat plus del del z k hat dot product with x square I hat plus y minus z whole square j hat plus xy k hat is equals to del del x of x square plus del del y of y minus z whole square plus del del z of xy. If you calculate it, it will be 2x plus 2y minus z plus 0. There is no z dependence in xy, explicit z dependence. So then divergence of v equals to 2 times x plus y minus z, and if you put this point 3 1 5, so divergence of v at point 3 1 5, it will be 2 times 3 plus 1 minus 5 equals to minus 2. So the correct answer is minus 2. So now in problem 5, you are given a vector field f, that is 2z plus 3x plus 5y k hat. So and you are given a surface, and you are given a surface where x equals to, this is the x component, x, y and z is the radius vector. So x equals to then r cos theta, y equals to r sin theta, and z equals to 4 minus r square. So basically the equation of the surface is x square plus y square plus z equals to 4. So if you do x square plus y square, you will get r square, and then if you add z, then it will be 4. So then z equals to 4 minus x square plus y square. So if you draw it, so to draw this surface, let's say this is 4. No, z equals to 4 minus r square. So if you do x square plus y square, you will get r square cos square theta plus r square sin square theta. That means this is r square, and if you put plus z, then it will be plus 4 minus r square. That means 4. So it is x square plus y square plus z. Now if you draw this, it will be parabola looking like this. This is z equals to 4 point. And so the integration, so you are actually do this surface integration where r is r belongs to 0 to 2 and theta belongs to 0 to 2 pi. So the radius vector basically this phi of r theta, it is given by r cos theta I hat plus r sin theta j hat plus 4 minus r square k hat. So you will find, so what we need to do is to calculate this integral f dot in ds, we need to find, so this f dot in ds, it means phi r cross phi theta d theta dr. So we need to find this n hat, which is the normal vector on the surface of the surface, and this phi r cross phi theta quantity. So phi r is given by partial derivative of this phi with respect to r, that is cos theta I hat plus sin theta j hat minus 2r k hat, and phi theta is partial derivative of this quantity with respect to phi with respect to theta. So then it will be minus r sin theta I hat and r cos theta plus r cos theta j hat, and there is no theta dependence here, so it will be 0. So then the normal in a normal vector on the surface, it is given by phi r cross phi theta. Sorry. So if you do this cross product, it will be I hat j hat k hat cos theta sin theta minus 2r minus r sin theta or cos theta 0. So then it will be I hat minus 2 r square cos theta plus j hat j hat 2 r square sin theta plus k hat r, because there is sin square theta plus cos square theta, so that is 1. So then unit vector is given by this normal vector by its magnitude, and its magnitude if you calculate it will be root under 4 r to the power 4 cos square theta plus 4 r to the power 4 sin square theta plus r square, and here it is, so if you take r common then it will be minus 2r cos theta I hat, which component? Okay, it is plus, yeah. Yes, so 2r sin theta plus j hat plus r, sorry r, taken r outside, so it is only k hat. And now this, if you take 4 r to the power 4 common, then it will be sin square theta plus cos square theta, that is 1. So then it will be, and then if you take r square common, then it will be r put under 4r square plus 1 and r 2r cos theta I hat plus 2r sin theta j hat plus k hat. This r and r will cancel, so then n hat is 2r cos theta I hat plus 2r sin theta j hat plus k hat by root under 4r square plus 1. And now this phi r cross phi theta, magnitude of phi r cross phi theta, that is given by basically magnitude of n, and you have already calculated the mod of n, that is r root under, so this one, this is r root under 4r square plus 1. So then integration f dot n ds is given by, so f dot n, f is 2z 3x 5y, 2z 3x 5y, and n hat is dot 2r cos theta 2r sin theta 1 by root under 4r square plus 1, but there is 4r square plus 1 here, so they will cancel, and times r dr d theta, where r is going from 0 to 2 and theta is going from 0 to 2 pi. So theta equals to 0 to 2 pi and r equals to 0 to 2. Now to do this dot product, it will be, so z means uh, z means 4 minus r square, so it is then 4 times 4 minus r square r cos theta plus 3x times this. So x is r cos theta, so that means 6 r square 6 r square sin theta cos theta plus 5y times 1, and y is r sin theta, so that means 5r sin theta times r dr d theta, and theta is going from 0 to 2 pi. So now if we do this theta integration fast, then there will be some function, and there will be some integration with respect to 0 to 2, there will be some r dependent function, and then cos theta integration from 0 to 2 pi full period d theta plus, so there will be some r dependent function, and 0 to 2 pi sin theta cos theta, so we can write it as 3 r square sin 2 theta. So it's basically 2 sin theta cos theta equals to sin 2 theta. So it is some function of r, and it is sin 2 theta d theta plus here again some function of r, integration 0 to 2 pi sin theta d theta, and whole times so dr. And now if you do this integration, so in a whole period, these are all periodic function. So then if you do this integration of cos theta, so cos is like, so this is pi, this is 2 pi, then cos function is uh, like this. So in a full period, if you calculate the area, it is basically 0. This one, if you calculate this area, it is 0. So integration of cos theta d theta in a full period, it is 0, and this is sin 2 theta, so it has a period of I. So basically it is twice the period you are integrating, so that will also be 0, and for sin integration sin theta d theta, it will also be 0. So basically, so these terms are 0, so basically it is 0 plus 0 plus 0, and the answer is 0. So the answer of this surface integration, that is 0. Manideepa is writing 2r square cos theta. Yeah, I think I put r outside here, so this r is fine. So anyway, this r will not matter because this theta integration will is giving us 0. So in problem 6, so we are given a surface, so triangular surface, and cut from the plane x plus x plus y plus z equals to 1 by the first octave. So if we draw it, then it will be, so it is x, y, z. So then when yz equals to, when we are in the x-axis, then it is cutting the x-axis at x equals to 1. That means when yz equals to 0, x equals to 1. So it is cutting x-axis at this point. It is 1, 0, 0. It's cutting the y-axis at this point, 0, 1, 0. And the plane is cutting the z-axis at this point, that is 0, 0, 1. So the plane will look like this. This is the triangular plane, and this is the vector field given, f equals to y I hat plus x z j hat plus x square k hat, and then we are asked to find out line integral throughout this boundary of this plane. So we have to find out this line integral. Okay, so let's call it point 1, let's call it point 2, and let's call it point 3. So it's a closed surface, so you can anyway apply this Stokes theorem to calculate to transfer this line integral to the surface integral and to the surface integral. But anyway, surface integral will not help because it's not an easy surface to integrate. So let's calculate a line integral then. So here, if so for the path 1 to 2, so basically if we want to calculate the line integral in the entire path, this del s f dot n hat ds. So here n hat is the direction of this line, so this is the n hat. So for path 1 to 2, n hat is this one, for 1 to 2. For path 2 to 3, n hat is this one, and for path 3 to 1, n hat is this vector, unit vector along this direction. So f dot n hat ds, we can write it as going from path 1 to 2, point 1 to 2. So along this path, f dot n 1 to 2 ds plus from 2 to 3 f dot n 2 to 3 ds plus f dot n 3 to 1 ds, integration from point 3 to 1. So that will cover the entire path. So we will calculate each of these integration separately for the three paths, and we will add them up. So let's calculate then from 1 to 2, point 1 to point 2. So as we are going along this path, point 1 to 2, we are on this xy plane, and this unit vector is given by, so it is given by then, it's a vector from 1 0 0 to 0 1 0. So that means it is given by n of 1 to 2, that is given by position vector of point 2 minus point 1. So position vector of, let's say, point 2 minus position vector of point 1 by magnitude of position vector of point 2 minus point 1. So which is given by j hat plus j hat minus I hat. So this R2 is j hat and R1 is I hat. So it is j hat minus I hat by the, if you calculate the magnitude, it will be root 2. And okay, and along this path z equals to 0, we are in the xy plane. So z equals to 0 along this path, and from this equation of this plane, if we put z equals to 0, then we will get the equation of this line, which is x plus y equals to 1. So x plus y equals to 1. So then if we calculate this integration from 1 to 2 f dot n 1 to 2 ds, this ds is given by root under dx square plus dy square equals to, so this f dot from 1 to 2, if you calculate f dot n hat, this n hat, then it will be, so there is minus I hat here and there is y here, so it will be minus y, and for the j component, so there is xz j hat in the f, and here is plus j hat, so it will be plus xz, and there is no k component. But notice that in this path from 1 to 2, z is 0. So that means this term will also vanish, because along this path z is 0. This is the, and by root 2. This is the f dot n vector, inert vector. And now ds, we can replace, so you can replace x as 1 minus y, and then dx equals to minus dy. So we basically can write here dx square, so dy square, in place of x we can write y, dx we can write dy, it is dy square plus dy square, which is root 2 dy. So it is root 2 dy. So we basically have minus y dy, and along this path point 1 to point 2. Now point 1 to point 2, y is going from 0 to 1. Okay, here y is 0 and here y is 1. So we write the y limit from 0 to 1, and we will get, so integration will be y square by 2 minus from 0 to 1, that is minus half. This is the line integral along this 1 to 2, along this 1 to 2 point 1 to point 2. And now you calculate this second integral point 1 to point 2 to point 3. So here the n vector will be, n hat vector will be, so point 2 to point 3. Here the n hat from point 2 to 3, it will be, so it is positive along the z axis and it is going along negative along the y axis. So it will be minus j hat plus k hat by root 2, and in this line x equals to 0, because we are in the zy plane, yz plane, so x equals to 0, and that means the line equation of the line is given by y plus z equals to 1. So now if we calculate this line integral from point 2 to 3, f dot n 2 to 3 ds, it will be, so f is given by this, so if we do this dot product, then it will be, so minus j hat in the n, and there is xz here in the f, so it will be minus, it will be plus xz plus, and here plus k hat, and here x square in the k hat component, so it will be x square by root 2 ds, and the path is from point 2 to 3. Now if you notice point, so in this path where, so point 2 to point 3, we are in the yz plane, that means x equals to 0 for this path. So it means here x equals to 0, here also x equals to 0. So basically this term is 0. So the integration will be 0. So from point 1 to point 3, the line integral will be 0. And then the last part is point 3 to point 1. So along this line, the n hat vector, the unit vector along this line will be n hat from 1 to 3. So it will be, so it is positive along x direction and negative along z direction. So that means I hat minus k hat. And in this plane y equals to 0, in this xz plane, that means for this path y equals to 0, and the equation of this line will be then x plus z equals to 1, or z equals to basically 1 minus x. So then ds, if you calculate, it will be root under dx square plus dz square. So if we replace this dz by dx, then dz equals to minus dx, so dz square will be minus dx square, so it will be dx square plus dx square, that is root 2 dx. So and now if you calculate this line integral, so point 3 to 1 f dot n hat 1 to 3 ds equals to 0.321. So f dot n hat, the I component, so I component of f is y, so then it is y, and here it is k component is -1 for n hat, and here it is x square, so it is minus x square. So there is a 1 by root 2 here in the n hat, and in the ds there is a root 2 dx. So now in this path 3 to 1, we are on this xz plane. So basically y equals to 0 for this path, and we can write y equals to 0 here, so y will vanish, and what we have is minus integration of x square dx, and x is going from, so from 3 to 1, x is going from 0 to 1, so integration limit will be 0 to 1, and now if you it will be x cube by 3, limit 0 to 1, so it will be minus 1 by 3, and then we will add these three integrations, and we will get the whole integration along this closed path. So then the integration on this it will be f dot n ds equals to, so along this path 1 to 2 integration is minus half, path 2 to 3 its value is 0, and path 3 to 1 it is minus 1 by 3. Minus half minus 1 by 3, which is minus 5 by 6. So the correct answer is the first one. Okay. So in the problem 7, here is again a, so f is given and the surface is given. So again a surface integral. So it will be long, I think. So if I get some extra time in at the end, I will solve it. So it is similar to this problem 5 actually. So here also, I mean, it is a surface integral of f. So if I get some time at the end, I will solve it. Otherwise, I will solve it and upload it after the class, because it will be long. Now problem 8, we are given a vector field and a surface. So the surface is a cube bounded by this plane x equals to a, y equals to b, z equals to c, and the axis and the coordinate planes. So that means the surface would look like this. So if this is the x equals to a point, and this is the z equals to c point, sorry, this is 0 0 c, this is, let's say, 0 0, sorry, a 0 0, and this is 0 b 0, y equals to b. So then y equals to b plane, so it will basically be a cube. So if you draw it, it will look like this. So this plane is basically y equals to b plane, and this plane is z equals to c plane, and this plane is uh, x equals to a plane. So we are asked to find the surface integral on this on these planes. So basically if, so we are asked to find out surface integral f dot n ds on these three planes. So this plane, this plane, this plane, and this plane. Now if we find out, so if we see, so let's call these three surface as S, and so if we enclose this cube, so there are this xz plane, this yz plane and xy plane. So let's assume that, so let's say this integration is phi, let's say phi s, and if we do surface integral along this other planes of this cube, that is the planes bounded by this xz plane, yz plane, and this xy plane, so then let's call it as 0. So f dot n ds equals to, let's say, phi of s0. So then the entire, so then if we add them, phi of s plus phi of s0, then it will cover the entire surface of this cube. So basically we are getting a closed surface, and we can apply Gauss divergence theorem to convert this surface integral in this closed cube to a volume integral. So then this phi s plus phi 0, it is basically closed surface s plus s0 and f dot n ds. And now if we apply the Gauss divergence theorem, it will be volume integral over this volume of the cube and divergence of f dv. So now if we calculate this divergence of f, so this divergence of f is given by this. So if we calculate divergence of f, it will be del x of this quantity, so which is 2x plus del y of this quantity, which is 2y, and del z of this quantity, that is plus 2z. This is the divergence of f. So now if we write it here, so it will be, if we take 2 outside, then it will be x plus y plus z, and dv is dx dy dz, and x is going from 0 to a, y is going from 0 to b, z is going from 0 to c. So then this integral to calculate, so if we calculate individually, then we will get, so for x integration here we will get x square by 2, and then there is this dy dz integration from 0 to b and 0 to c, plus if we do this y integration here in the second term, then it will be x square by 2 from 0 to a. So it will be y square by 2 from 0 to b, and then there will be dx and dz. So x is going from 0 to a, z is going from 0 to c, plus for the third term it will be z square by 2 and z is going from 0 to c, and there will be integration with respect to dy, dx and dy, and x is going from 0 to a, y is going from 0 to b. So 2 times, so this term is basically a square by 2, this term is basically b square by 2, and this term is c square by 2 if you put the limit. And if you do this y here, if we do this here, if we do this y and z integration, we will get y and z, and then if you put the limit, it will be c times b. So we will have a square cb by 2, plus here we will get, if you do this x and z integration, we will get c times a. So we will have a b square c by 2, plus if we do this last integration, we will get a b c square by 2. So then if we take half abc common, so then half and 2 will cancel, then we will get abc times a plus b plus c. This is the volume integral, and this is basically the surface integral of this vector field throughout this entire surfaces of this cube. But we are asked to find out the surface integral on this only these three surfaces: x equals to a, y equals to b, and z equals to c. But now, if you notice here, mm, so for this for let's say for this yz plane, so surface on this yz plane, surface on this yz plane, the normal vector will be along the x-axis. So now if you do this integration along this surface of this yz plane, so then f dot n hat, so n hat is along this y-axis for this yz plane, sorry, along this x-axis. So f dot n hat will be then uh, f dot n hat will be then this only this term, and in this plane, so if you do this surface integration, you will basically there will be basically no variation of x, and you will basically get a 0 on these other surfaces. So basically these three surfaces will be 0, and so this phi of a0 will be 0, and basically we are getting this phi of s. It is basically the volume integral of divergence of f dv, that is abc times a plus b plus c. So the correct option is third one. So now in this problem 9, so here again we are asked to find out a surface integral. So there will be a ds here, f dot n ds equals to what? So okay, I will do it. So I already did one surface integral, so I will do it later. So let me see what is problem 10. Okay, so we are given f equals to this quantity, and f dot this del vector that is given by this, and we are asked to see that whether this relation is right or wrong. So if 1 is given by m1 I hat plus n1 j hat plus p1 k hat, and if 2 is given by n2 I hat plus n2 j hat plus p2 k hat. So let's call it LHS. Let's call this is as LHS, and let's call it as RHS. So then first calculate LHS then, and then we will show that it matches with RHS. So we'll calculate this LHS and RHS individually. So first let's calculate F1 cross F2. So F1 cross F2, it is I J K M1 N1 P1 M2 N2 P2 equals to I hat times N1 P2 minus N2 P1 plus J hat times P1 M2 minus M1 P2 plus K hat times M1 N2 minus M2 N1. So now if you again take the curl of this quantity, so it will be a very big quantity then, F1 cross F2. So if you take this curl, it will be j. No, actually, if you take the minus, then I mean I have interchanged here. Okay, so if you take the minus, then you have to interchange these two terms. So I hat, j hat, k hat, and it will be del x, del y, del z. I component is n1 p2 minus n2 p1. Y component is p1 n2 minus n1 p2, m1 n2 minus m2 n1. Okay, so okay, let's calculate then for only the x component of this LHS, and let's compare it with the x component of RHS, because there is no preference of xyz here. I mean all are in the same footing. So if we show that x component of LHS is equals to x component of RHS, then the other components will follow. So LHS, and in the suffix I am writing x, it means x component of LHS. So it is basically, so this coefficient of I hat, that means del y of m1 n2 minus n2 n1 minus del z of p1 n2 minus p2 m1. So if you do this derivative, it will be m1 times del into del y plus n2 times del m1 del y minus n2 times del n1 del y minus n1 times del n2 del y, and minus this term. So if you do this derivative, it will be p1 times del m2 del z minus m2 times del p1 del z plus p2 times del m1 del z plus m1 times del p2 del z. So this is the x component of LHS, and now let's find out this x component of RHS. So then, so x component, so x component of RHS will be basically x component of this, x component of this, x component of this, and x component of this. So f2 dot this nabla operator, it will be, so f2 dot this operator, it will be this m2 del x plus n2 del y plus p2 del z. Similarly, f1 dot this operator, it will be m1 del x plus n1 del y plus p1 del z. Similarly, divergence of f1, it will be del m1 del x plus del n1 del y plus del p1 del z, and divergence of f2, it will be del m2 del x plus del n2 del y plus del p2 del z. So now if you calculate this quantity, so then here, so x component of this term, it will be this term times x component of f1. So basically RHS, x component of RHS, it will be F2 dot this nabla operator, F2 dot, sorry, F2 dot del, and x component of F1, that is M1 minus, sorry, there is F2 minus, so here F1 dot this operator times x component of F2, and that is M2. So F1 dot operator times M2 plus divergence of F2 times x component of F1, that is M1. So divergence of F2 times M1 minus divergence of F1 times M2, the x component of F2 vector. And now if you calculate it, so this quantity is we already calculated here, so it will be M2 del x of M1 plus N2 del y of M1 plus P2 del z of M1 minus for this term it will be M1 del x of M2 minus N1 del M2 del y minus P1 del M2 del z, and then this term, so it will be M1 times del M2 del x plus M1 times del N2 del y plus M1 times del P2 del z minus this term, so it will be M2 times del M1 del x minus M2 times del N1 del y minus M3 times, sorry, M2 times del P1 del z. So now if you see this, there is a plus sign. So this M1 del M2 del x, and here there is minus del M2 del x, so these two will cancel, and these two terms will cancel. So we basically have, so these two terms, this term, and there is M2. Yeah, these two terms. So these two terms will be del y of M1 N2, and these two terms, so N1 M2 this term and M2 N1. So these two terms will be minus of M2 N1, del y of minus of M2 N1, and plus del z of, so these two terms, so this term and this term, it will be del z of M1 P2. So M1 P2 minus, so and plus, so there are these two term and this term and this term, so it will be del z of minus P1 N2. So which is basically this x component of LHS, del y of m1 n2 minus m2 n1. This is del y of m1 n2 minus m2 n1, and del z of m1 p2 minus p2 p1 m2. So p1 del z of p2 m1. Yeah, so if we interchange this, there will be a minus sign. So if we interchange this, here will be a minus sign, and there is a minus here, there is a plus here, so then these two will match. So minus del z of p1 m2 minus m1 p2. So minus del z of p1 m2 minus m1 p2. So LHS of x equals to RHS of x, and similarly you can prove the other components also matching. So it means that the following relation is true. Okay, so 1 hour is over. Let me calculate this problem 9. Then the other one I will solve after the class and upload it. So here, so basically we are asked to calculate the surface integral in the first octant. So first octant means only where x greater than 0, y greater than 0 and z greater than 0 here. So in this surface. So in this surface, so the radius is, so anyway it is r square, x square plus y square plus z square equals to r square. That's the equation of the sphere in 3D. So r is 2 and theta, so if we call this as theta, this is the xyz, this is a radius vector r. So if we term this as theta and this angle as theta and this angle as phi. So then theta is going from 0 to 2 pi. So theta belongs to 0 to pi by 2. So from z axis to this xy plane, and phi is also going from 0 to pi by 2. As we are in the first octant. So we are asked to find out this surface integral. So n hat, for a sphere n hat you can calculate easily. It is a unit radius. It's a radius vector. Unit vector along this radial direction. So it will be basically x I hat plus y j hat plus z k hat by root under of this x square plus y square plus z square, which is basically the radius vector, magnitude of this radius vector. Sorry, magnitude of radius vector is r, and r equals to 2. On this surface, r equals to 2. So f dot n hat will be then 1 by 2 1 by 2 x cube plus, sorry, minus 2x y square plus 3x z square. So equals to, if we replace it by r theta and phi, so it will be 1 by 2. Here will be an r, so x equals to, so x equals to r sine theta cos phi. This component is r sine theta basically. So x will be r sine theta cos phi. Y equals to r sine theta sine phi. Z equals to r cos theta. So if we So from every term there will be r cube. So we can put this r cube outside. So then we will have sine cube theta cos cube phi minus 2 times. So here is a sine theta cos phi, and here for y square there is a sine square theta and sine square phi. So it will be sine cube theta sine square phi cos phi plus 3 times x is sine theta. So r we have already taken outside, so it is sine theta cos phi, and z is cos theta. So it will be sine theta cos square theta z square and cos phi. And this ds, so in the last class we already calculated this ds, which is basically phi of theta cos phi times d theta d phi. So already calculated this in the last class. So it comes like r square sine theta d theta d phi. So which is basically r square means 4 because r is 2. So 4 sine theta d theta d phi. So the surface integration will look like, so f dot n ds equals to, so f dot n, there is a half here and in the ds there is a 4, so we can put 2 outside, and there is r cube. So r is 2, so r cube is 8, so that means 2 times 8 is 16. So let's put 16 here, and then the integration, and f dot n, from f dot n we are getting this sine cube theta cos cube phi, and there is a sine theta here in the ds, so it will be sine to the power 4 theta cos cube phi minus 2 sine to the power 4 theta sine square phi cos phi, so minus 2 sine to the power 4 theta sine square phi cos phi, sine to the power 4 is because there is a sine theta in the ds, and here we will get 3 sine square theta cos square theta cos phi plus 3 sine square theta cos square theta cos phi d theta d phi, and phi is going from 0 to pi by 2, also theta is going from 0 to pi by 2 because we are in the first of term. And now if you do this integration, so I have already done this integration, I'll just write the answers. So if you do this okay, so if you do this phi integration cos cube phi d phi from 0 to pi by 2, it will be 2 by 3. If you do the sine integration, it will be 3 pi by 16, and if you do here this phi integration of this sine square phi cos phi, you will get 1 by 3, and if you do this theta integration here sine to the power 4 theta, then you will get 3 pi by 16, and here if you do this theta integration you will get pi by 16, and if you do this phi integration from 0 to pi by 2 you will get 1. So now if you see there is, so 3 pi by 16 times 2 by 3, and there is a minus sign here, and again this 2 multiplied with 1 by 3, that means 2 by 3, and it is multiplied with 3 pi by 16. So this term, these two terms will cancel basically after the integration obviously, and so we have 16 outside, and after the integration, so there is times 3 times So after the integration, after the theta integration, we will get pi by 16, and after the phi integration, here it will be 1. So we will basically get 3 pi. So the correct option is the first one. Okay, so we are already out of time. So I will solve this last problem and upload it. And this is the last class. So best of luck for your exam. I think it is on 25th. Okay, so that's all for today. Let me stop sharing.